This example is asking us to find the indefinite integral, which means we're going to get an equation back out of it. You know it's an indefinite integral because you don't have any bounds on that integral symbol. So the indefinite integral of the sine of x dx. Remind yourself that this symbol up in front, that's just saying take the antiderivative of this stuff, and then the dx is just telling us what variable we care about. So what we're looking at is always what we want to take the antiderivative of is what's sitting in the middle of those two things. When we're going to take the antiderivative of a trig function, when you learn derivatives of trig functions, remember those were something you just had to memorize. And so guess what? When you're undoing the derivatives, taking antiderivatives of trig functions, they're also going to be something that you need to have memorized. So this is what I just refer to as a special case antiderivative, something you just have to know in order to get it. So the special case we're looking at here is whenever we have the sign of a number times x. If we can remember it with this number inside here, it's really going to save you on some more complicated problems later on. What this ends up becoming, this is going to be 1 over a, and then sine came from cosine. But the thing here is it should have had a negative because cosine should have given us negative sign. So this is going to be negative 1 over a, and then the cosine of ax plus c. Whenever I write the special cases down, I always use the indefinite integral form and put that plus c on the end. So you just got to have these memorized. Looking back at our sine function right now, there's an unwritten 1 in front of that, so that is our a value. So what we would get out of here is we'd technically get negative 1 over 1, and then sine came from cosine, and then you'd technically still have that 1x inside there, but we don't really need the 1, so we'll leave that out. And then when you're doing indefinite integrals, you always put a plus c at the back end here. This is how you get a family of solutions, all of them varying by whatever that constant was. We don't know if it was there or not because the derivative of any constant is 0. So we track the fact that there could have been a constant there by always putting that plus c in. Simplifying this down, you could maybe just turn that into a negative and then cosine of x plus c, and that is your indefinite integral. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.